So, with permission with everyone, I have been switching on the recording. So, guys, I have been starting the session. So, let me tell you the things that we will be covering today. So, as per my discussion, so I'll be starting with the basics of machine learning, and I'll go into the Python as well in the middle of machine learning. So I'll cover the some of the things of Python, but along with the machine learning only. So I'll not take separately the things for Python, but initially we'll start with the machine learning only, and I'll keep on going or deep diving into Python during the interim of the some of the sessions. So today we will be starting with uh, machine learning. So how many of you have an idea like what are the types of machine learning, supervised, unsupervised, and all the things? Do you have any idea, or do you want me to start from there? If you have any idea, if you want me to start from the scratch of the machine learning, that what is supervised, what is unsupervised, what is reinforcement, and all other things, I'll go with that. In case you want me to start with any other thing, then I'll go with that. So what I'll do today, so okay, so I'll assume that all of you want me to start with the scratch of the machine learning, and don't worry about the basics of Python. I'll go and deep diving that during the interim of the session. Not this one, but for the subsequent sessions. Sure. So let me share my screen with you, and you guys can start preparing your notes as well along with me. So I'll say I'll present my screen. Guys, one more thing. In case I get disconnected in between, then stay here only, and I will be returning back in case any technical issue comes, and I and I and you lost me. So can you see my screen? Okay, sure. I'm coming to this Word document. So I'll start machine learning. from scratch. And I'll keep on covering Python as well during the interim of the sessions. The people who are not aware about Python, they don't have to be worried. I'll cover that. So first I'm starting with machine learning from scratch. So machine learning,
Question. Sir,
yeah,
Isa this said I need to ask that we didn't receive the mail to connect with today's class.
come again.
Yes, even I was trying to join from the last old ID, and I was waiting for past around 10 minutes.
Okay, not a problem. So I guess from now onwards, this will be the link only. I also got this link from IIBM today only.
Okay.
Okay.
Okay, so I'm saying machine learning is the ability of the of the machine to learn basis historical data. Same thing. So in case you are not clear with any of the line I have been writing or any of the line which I have been speaking, then interrupt me in between. Okay. So machine learning has been divided into two parts. Basically two parts. There are some certain other things as well which I'll be going into. One is supervised learning and second is unsupervised learning. Supervised learning is a learning when we have the data available on which we have to predict. So I'm telling you. So what normally happens? So let's example. We want to predict uh, the level of rainfall depending on the different data set that we have available. I'll come into Excel to explain you. I'll come to this Excel to explain you. I'll say if
Hello, hello, sir.
yeah, hello.
Kindly start it. Kindly repeat it once. I have joined late.
Okay, so today I am repeating it, but from tomorrow I'll
Yeah,
be
I will. I will be there, sir, on time.
yeah, I'll be starting sharp at 8:50 and from tomorrow onwards. Okay, so today I've been repeating it for the people.
Okay.
Yeah,
Thank you so much, sir.
okay. So what I have started is machine learning. I'm telling something about the machine learning from the scratch. So machine learning is the ability of the machine to learn basis the historical data. Machine learning has been divided into two parts. One is supervised learning and second is unsupervised learning. So I was on the point where I have been explaining what is supervised learning. So I just took this example of this Excel sheet where I say age and salary. So let's example when my age was 21, my salary was 1,000 rupees. When my age was 23, my salary was 4,000 rupees. When 25, it was 10,000 rupees. When it was 27, my salary was 12,000 rupees. Now, when it is 50 years, the salary was 20,000 rupees. Let's example. So now this in this example, what I actually wanted to do, I want to know what will be my salary when my age will be 40 years. So I wanted to know what will be my salary when my age will be 40 years. So what normally happens in this scenario is we have two variables. So anything data that I'll be putting in Excel sheet is known as variable. I have two variables. One is age and second is salary. So what is the thing I want to predict? I want to predict the salary. So whatever thing I need to predict is known as dependent variable. The things I have with the help of which I want to predict is known as independent variable. Okay, clear till here? The thing which I want to predict is known as dependent variable. The thing which I have, so I wanted to know what will be my salary when my age will be 40 years. So here I have the age and I want to predict the salary. So salary will be the dependent variable and age will be the independent variable. So coming back to supervised learning, when we have data set where we have independent and dependent variables, then this falls under the category of supervised learning. So what is this dependent variable? This variable is guiding this, like when this variable is running only because of this dependent variable. So this variable is supervising this variable. The dependent variable is supervising the independent variable. So that's why this problem is known as supervised learning. With me? Anybody, any doubt? Okay, so considering you don't have any doubts, so I'll proceed. Unsupervised learning. Unsupervised learning is uh, this this is the type of data. This is the type of learning where we don't have dependent and dead relationship in the data. Here, I'll come to it through an Excel sheet. So let's example. I have certain data set. If a customer purchased milk, so customer number one, customer number two, customer number two. Customer one purchased bread, milk, and tea bags. Customer B purchased ice cream, chocolate and bread. So if we have this kind of a data set, then there is no independent variable that is there. So if I want to see how many of the people who purchased tea bag, what is the probability of buying milk? The people who purchase chocolate, what is the probability of buying bread? So there is no independent dependent variable relationship in the data. So what is this? So this is unsupervised learning. With me? So I'll keep on bringing you. Okay. So I'll whenever say any doubts, in case nobody responds, then I'll proceed. Considering nobody has any doubts. Okay. In case you have any doubts, then I'm with you. And just to set up the agenda, let me put it this way. So it's an initial class we have been starting with. So I will go slow in it. Okay. With time, I will be fast once you guys are clear with the concepts. Okay. So during the initial 2 or 3 classes, we'll take 2 breaks. Then I will go with, after 3 or 4 classes, I will go with 1 break only. Okay. I will take 2 breaks, one at 9:30 and second at 10:15. So this break will be 9:30 to 9:45. This will be only for 2-3 minutes. It's a bio break. To 10:20 at max. Then after that, I'll be going with 1 break only. In the after 4 or 5 classes, 9:30 for 5 minutes. 10 minutes, sorry. After that, there won't be any break. So this is the thing which I normally follow. Okay. So unsupervised learning.
Sir,
Yeah.
so I have a doubt regarding unsupervised learning. As you told that regarding the purchasing pattern, we have to cohort the pupil, like these type of pupil purchase that type of items. So do we know it priorly?
Come again. I didn't get the last line. Do we know?
It priorly in advance.
Okay. We have the historical data. I have not mentioned so machine learning itself is a thing which will consider historical data in place. But when we say unsupervised learning, I'll come to Excel sheet. So I don't know which of the variable is dependent variable, which of the variable is independent variable. Might be I'll say tea bag, third item. If a third item has been purchased, then what is the probability of buying the first item? Or the first item is being purchased, what is the probability of buying third item amongst the all customer data that I have? So there is nothing called dependent, nothing called independent.
Okay, suppose I am performing the k-means clustering in the data set, what you are talking about. So in that situation, like we grouped the pupil in customer 1 and customer 2. But how it comes to the situation, like what about the percentages when?
So in case you're going with the k-means clustering, then data will be like this. Say customer 1 has certain hobbies, customer 2 has certain hobbies, and in the similar way we have 1,000 customers. We want to arrange these customers into 5 clusters. So the k-means clustering will apply. So in this scenario as well, there is no independent and dependent variable relationship. So that's why this falls in unsupervised learning.
There is no target variable.
No target variable. So dependent variable is known as target variable as well.
Okay.
Okay. So coming to this, so now I'll tell you certain algorithms that falls under supervised learning and unsupervised learning. Within supervised learning, we have two kind of uh, algorithms. One is regression and second is classification. Before this, I'll come to some of the concepts. So let's example. I'll come to this only. Data types. So first kind of a data, I'll take an example, is a continuous data. Second data is known as discrete data. When we say continuous data is anything that can be measured in terms of the scale. Anything that go into decimals is known as continuous data. Anything that cannot go into decimals is known as discrete data. So I'll take an example. Say height. So I'll ask somebody, say Vijay Sai, what's your height?
Sir, 5'6".
Come again?
5'6".
5'6". So Vijay's height is 5 feet 6 inches. Okay, I'll say ask uh, Shubhangi Kumari. Shubhangi, what's your height?
5'4", sir.
Shubhangi said the height is 5'4". Okay, now this height, the height 4.1, 4.2, 4.3, anything. So this height has a capability, height as a metric has a capability to go into decimals. So this height is a continuous data. Anything that can be measured on a continuous scale is known as continuous data. Another example. So I'll pick a person, say Isha Jahan. Isha, how many
Yes, sir.
family members? No, I'm asking a different question. How many family
Yes,
members are there in your house?
sir. 6 members, sir.
6 members. So Isha said 6 members. So is there a scenario the members can be 6.5? No. The
No,
members can be
sir.
5.5? No. Because this metric, number of people, does not have capability to go into decimals. So this is known as discrete data. Anything that cannot be measured on a continuous scale is known as discrete data. So discrete data itself has certain parts. So discrete data itself has certain parts. First part of discrete data is first anybody any idea like what are the different parts parts of discrete data? I'll tell you. One is count, second is binomial, nominal, and ordinal. Discrete continuous data is very simple. Anything that can be measured on a continuous scale. Light, height, weight. Discrete data, anything that cannot be measured on continuous scale. Count is a number of family members that cannot go into decimals. So I'll tell the binomial. Well, I'll pick some other person. Say I'll pick Ranjit Ram. So Ranjit, if I'll ask you, are you married? So just ask a question from Ranjit. Is that Ranjit, are you married? I, I did not get the answer from Ranjit. I'll pick Samir Kazi. Samir, am I audible to you?
Yes, sir.
So Samir, are you married?
No.
No. Samir said no. Okay. So this is a binomial variable where we have only two outcomes. Outcome. That is true or false, yes or no. It is known as binomial variable. The second is nominal. Anybody any doubt on till the point we have covered the binomial variable?
No, sir.
Binomial data. Okay. Now the nominal data. Nominal data is the data like, okay, I'll ask somebody else. I'll ask say Shoaib Khan. So, which color shirt you are wearing today? The shirt is not. I guess I'm not audible to Shoaib. Shoaib, am I audible? Okay, I'll come to Ruju. Ruju, what is the color of your shirt?
Black.
Black. Okay. So I'll ask now Shraddha. Shraddha, what is the color of your shirt?
Red.
Red. So I got two responses. Red, black. If I'll ask somebody else, say Shivangi. Shivangi, what is the color of your shirt?
Some maroon.
Maroon. So the outcomes can be many, but the outcomes can so here the outcomes can be many: red, black, maroon, gray, white, and many more. But they cannot go into the decimals. So this is a nominal kind of data. When we have a categorical kind of outcome, so this yes, no, true, false, we call it a categorical output. Red, maroon, black, we call it a categorical output. So here the output is there, but it cannot go into, but it is not like it is a categorical count of our outcome, which can be more than two. So this is known as nominal data set. Another is, I'll say somebody else. So I'll say Raghuram. Raghuram, what is your weight? Raghuram said 70 kg. So I'll say Raghu said 70 kg. I'll ask somebody else. Say Sai Arjun. Sai Arjun, what's your weight?
81 kg.
I says 81 kg. I'll ask somebody else. I'll say Vijay Sai. Vijay Sai, what is your weight?
60.
He said, if I need to arrange all these three people on a certain kind of a rank, then I'll say the person with the highest, the lowest weight is rank 1, then rank 2, then rank 3. That's example. So I'll say rank 1 is Vijay, rank 2 is Raghu, and rank 3 is Sai. That's example. So I have categorized the data that I had on the basis of ranks. So I've ordered them in a certain scenario: rank 1, rank 2, rank 3. Basis their certain characteristics, weight, age, height, marks, or whatever. So the thing like rank 1, rank 2, rank 3. So anything that can be ordered, anything that can be ordered is known as ordinal data. So here, can I rank people basis their colors? The color of the shirt they have been wearing. Can I rank them? No. That's why it comes under the category of nominal data. Anything with the help of which I can rank is known as ordinal data. So I'll again ask my same question. Any doubts? Okay. Okay. So anything. So now the question is, we have been discussing what is a regression problem and what is a classification problem. So anything with dependent variable as continuous or discrete count is a regression problem. Anything with dependent variable being binomial, nominal, or ordinal is a classification problem. Anybody any doubt? Okay, very good. So we have certain algorithms that are known as regression algorithms, like linear regression, as a SLR, that is simple linear regression. Simple linear regression. Second is MLR, multiple linear regression. Third is decision tree. Fourth is neural network. Fifth is support vector machines. Fifth is anybody, any doubt till now? Anybody, any doubt? Yeah, I'll come to that. I've not completed yet. So Akash, I'll come to that. I'm just asking people in case anybody has any doubt. So because after this I'll start asking some of the questions as well, so I can ask with anybody. So I just want to make sure anybody has any doubt till now. I'll cover those algorithms, but I just wanted to know if anybody has any doubt. Okay. Random forest is nothing but a extension of decision trees. Okay, I'll come to that as well. So this is known as ensemble learning. I'll come to that. Classification has certain algorithms like naive Bayes, logistic regression, KNN algorithm, decision trees both classification and regression both. So what is the random forest as well? I'll explain you how. Neural network and support vector machine are again both can be used in both the kind of problems. These are basically used in both the kind of problems. When I say unsupervised learning, it again has certain types. One is MBA, that is market basket analysis. Second is clustering. These are the commonly used algorithms for unsupervised learning. These are the algorithms for regression problems. These are the problems for classification problems. Anybody, any doubts till now? Okay. Okay. So now what we will be doing, I will be starting with the algorithm like the simple linear regression. This algorithm. I'll explain this algorithm in detail to you guys, and uh, after every 1 day or 2 days, depending on the algorithm, we will be starting the new algorithm for in the new class. So might be today we'll start with the simple linear regression. Then most probably tomorrow I'll be ending with simple linear regression and coming to the next topic, that is multiple linear regression. In the meanwhile, I'll stop somewhere for explaining some of the Python concepts as well, so that it is fine with all kind of audiences. Okay, so initially, for the people who are new in this into this batch, I have been taking a 15-minute break so that they can revise. So I'll keep this on a screen sharing mode with bit lower in size so that you can read it completely. I'll remove this so that you can read it completely, and you can take your um bio breaks or whatever you wanted to. Welcome. These are the things which we have seen till now. So you guys can revise it. I know for the people who are like bit experienced into it can take the breaks. People who are new to it can take 5 minutes to revise it. Then after this, I'll be asking some of the questions with the random people I can pick, and after that, I'll be starting with simple linear regression. Is it fine with everybody? I've been waiting for responses. Okay, sure. So I'm putting this on screen sharing mode, and you guys can see it, and then I will ask questions after this with the random people. Hi team, so I'm back. So did you get a chance to go through the document?
Yes, sir.
Any doubts? Anybody has?
No, sir.
Okay. Okay.
Hi, sir.
Yeah.
Hello. Sir, I have a doubt. Like you said about data types, right? In those data types, does interval and ratio scale comes under?
Yeah. So that will come under. So that is interval ratio as well, but that was not covered. That is not required for the machine learning, so I didn't cover.
Okay. Like I have an idea. I have a doubt. The what does the like in uh, the the growth rate of crop, like the production of crop, what
Mhm.
does it comes under, sir? Like it comes under discrete or continuous?
Yeah,
Because it might be in decimal too, right?
yeah. So I'm coming to that only. So there are
Okay.
certain data types like accuracy. Accuracy is number of errors divided by number of cases processed. Both are discrete, but the outcome that is coming is a thing that is going to be a continuous. So it is not continuous, but it can behave like a continuous. So you
Oh,
can consider it as a continuous data set. But since it is coming from a discrete data set, so you can't say it is a pure continuous, but it can be treated as continuous data set.
okay. Okay, sir. Okay. Thank you.
Anybody else? Any doubt? Okay. So, I'll pick somebody. I'll pick the fourth person from the top. One, two, three, four. So Isha. So Isha, the question for you is, if I have a if I have been measuring the amount of water the bottle has, the amount of water the bottle has.
Sorry.
So if I have been measuring the amount of water a bottle is carrying, so which kind of a data set it will be?
Amount of water. You mean continuous or discrete?
Yeah, which like binomial, ordinal, nominal, count,
Okay.
continuous, what kind of a data set it is?
It should be continuous.
Yeah, you're right. It's a continuous data set. I'll ask from Khushbu. So Khushbu, my question to you is, can you please name any of the regression problem? Khushbu, am I audible? Okay, not a problem. So I guess I'm not audible to Khushbu. Okay. So I'll progress with the next part of the problem, that is simple linear regression. So I'll open a paintbrush. The example which I have taken, age versus salary. So let's example, it's a two-dimension plane. So I've been saying, if my age is 21 year, my salary was 1000 example. So here will be the total. When my age was 23, my salary was say 3000. So I'll put it here. In a similar way, I'll put some more dots, some more here, and it comes as here. So this was the graph that will be plotted if I go to this data set which we have just explained. 21, 23, 25, 27, 30. On 25 it was 10,000, so it will be something like this. 25 it was 10,000, so it will come somewhere here. These are the different points that will come. Now let's say example I draw a straight line here. Like this. This is straight line which I have drawn. So now this line is passing through the middle of all the data points with the minimum errors. So there cannot be any other line which is so closest to these points. This line can be in any other shape as well. Say this line can be like this, or any shape. So the line that will pass through the closest of all the points will have the minimum error from the points that I mentioned. This is known as best fit line. So if I extend this line, now let's example I want to know what will be my salary when my age will be 40 years. Okay, how much? 40 years. So if I'll extend this line, okay, like this, and I'll take this up, and this is the point, and I'll take this point here, and it says, let's example, it says 40,000. So I can predict if my age will be, so this is the age, this is the, so if my age will be 40 years, then my salary will be 40. So with the help of this, I have this existing data set. This existing data set I had, and with the help of this, I have predicted my salary when my age will be 40 years. So this is simple linear regression. I'll come to the properties of this line, but before that I just need to ask from you guys, any doubt? Okay. So this line, when this line has been drawn, I've been drawing another graph because this graph is looking a bit dirty. Like this. The line that came was like this. Okay. Now let's example, I'll extend this line. Like this. If I extend this line like this, then this line will cut somewhere on the, so which axis is this? Is this x-axis or y-axis? This is x-axis. This is y-axis. Our x-axis is age. Y-axis is salary. So the point where this line cuts on the x-axis, sorry, y-axis, this point is known as intercept. And if I draw a line just parallel to x-axis from here, okay, and the angle which it forms is known as slope. I'll again come here. I'll say any doubts? Okay. If I'll come back to this. Okay. I'll come to this. Here the problem was I need to estimate what will be my A salary, well my age will be 40. Well, if I simply say is equal to, and sorry, before that, this line follows the equation that is y is equal to mx plus c, mx plus c plus e. This m is known as slope. This c is known as intercept, and this e is known as error. I'll come to this. So you don't have to calculate this all the time. So this equation, this will be made automatically. I'll first show it in Excel, then I'll go to Python as well. I'll say the equation is y is equal to mx plus c plus e. So m is what? Intercept. C is what? Slope. I'll say is equal to intercept in known y's. What is a y? Y is a dependent variable. That is salary. Known x. This is age. I'll say enter. It's saying intercept is minus 43582. Sorry. M is slope. M is slope. E is intercept. I'll say, so here I'll say is equal to slope. Known y's, the known y's, known x's, the known x's. Slope is this one. Intercept is equal to INTERCEPT. Known y's, one known x's. This is the intercept. If I'll say is equal to m, this one, multiplied by age plus intercept, which is 40,516. So it is saying 40516. So the system has predicted that my salary will be 40,516 when my age will be 40 years. So this equation, system has automatically calculated this M, this C, everything system has automatically calculated and given us the value that is 40,516. So this is nothing but the regression equation. Anybody, any doubts? Yeah. Yeah, I'll come to, don't worry. So till now,
Sir, can you please show once how you calculated M and C?
yeah. So it's is equal to slope, is equal to intercept, and you'll select the range. So I'll say is equal to slope, known y's are the y's, known x's are the x's, yz, enter, that is slope. Similar is the way intercept, known y's, known. Welcome to E Alka. Any doubt till now? Okay. I'll take a 1 minute pause here just to highlight the Excel sheet. In case anybody has any doubt, then just have a look for 1 minute over the Excel sheet and I'll ask some questions after that. So I'll have a question that how did I calculate the value of y? What is the equation? Y is equal to m. The value of m is base multiplied by x. What is the x? I'm going to calculate 40 plus c. C is this one. This is the way I calculated the value of y. This y. Okay. Now I'll come to next thing, that is E. So if I'll ask this equation to calculate the value when my salary was 21. So instead of How it will calculate? F5 m multiplied by x. So x is this one. It's saying 569.6. So 570 something. 570. What will be my salary when my age was 23? This one. It's saying 4774. So in a similar way, if I keep on calculating this, so there's a difference. It was 4000 and it calculated 4774. So what is this? This is an error. System, whatever system is predicting is with some error. So error is nothing but this minus this, or this minus this. If I average this error out, let's example the error comes to 500. The average of error comes to 500. Then I can give the confidence interval that whatever y will be predicted, it will be plus minus 500. So this is error. This is plus E. Are you fine or is any doubt? So after this, I'll go into the Python and I'll start.
Sir,
Okay, error part.
sir, I got a question.
So you want me to repeat the error part?
No, sir, I got a question. In SLR, we have only one dependent variable, right? And we can have one or more independent.
So in case of a simple linear, good question. In the case of a simple linear regression, we have one independent and one dependent variable. In case of MLR, multiple linear regression, we have multiple independent variables, but have a single dependent variable.
Okay.
Hello.
Hello.
Sir, how E is calculated? Please repeat it once.
Okay. So E is nothing but this is actual salary. This is predicted salary.
Okay.
If the value was 1000, but our system is predicting it to be 570. The value was 4000, system is predicting it to be 4774. So this is actual, this is predicted. Error is nothing but actual minus
Actual minus, yes.
predicted. So this is
So
minus.
how we can calculate E? That's what I am asking, sir.
Okay. So we have the value available 21. But
Yes.
age is 21, salary was 1000. Okay. But this equation is giving me, this equation has been made using this line. So one point is here, one point is here. So this line passes from here. So from every value, this line is has a certain difference. So this is nothing but a error. This is the thing which I've been telling you here. Actual value is 1000. So actual value is in this is 1000. Let me this
Okay.
is 1000. System predicted this value as 570. Let's example. 570. The difference is error, and that is minus 430. So with this value, 430 is the error. With this value, 774 is the error. If I'll keep on predicting the things, for example, final error comes to 500. So this is the final error of this data through linear regression. Any doubt? To Arjun and Tell again. Okay, Arjun, no doubt. Shubhangi, any doubt?
No, sir.
Okay. So which Python? So when we say Python, when we say Python, coming to this, Python has various consoles like Jupyter, Spider, console, and many more consoles as well. These are known as Python IDEs. Python IDEs. ID means individual distributed environment. You can opt for any of the ID. Normally, I opt for Spider. This is the way how Spider looks like. This is a console for coding. This is a coding part, coding area. Here you will get like what are the variables that have been made and all the things. So here we have different options like help, and here we will get the outcomes that we are processing. So I'll tell you some of the other things as well, like the source and all the things once we progress over here. So here is the area where we write the codes. Okay, any doubt? Whenever we work on Python, we keep on importing the libraries. So what is the benefit? Okay, so before I proceed, so uh, how many of you are new to Python? From new I mean how many of you have how many of you are having this as the how many of you know Python? So how many of you know Python? With this I mean how many of you uh, have not attended. Okay, I'll rephrase my question. How many of you don't know Python? How many of you don't know Python?
Hello, sir. Hello.
Yeah, hello.
Sir, I know about basic things like if else, loop, and all of that, but I don't know about the module things, NumPy and Matplotlib, anything. I don't know
Okay,
about it.
okay. So that's the thing I'll cover in this session. So I'm just asking
Okay.
people who have never seen Python or it's the first time they have been seeing the Python.
Okay. I know about the basic things.
Okay. Title is fine, Shivangi. So that's the ID only. So if anybody can answer my the last question which I have asked in the chat book. How many of you don't know even basics of Python? Okay. Report pandas as PD. Yes, and okay. Okay. Let me restart. But that is it. Still open to the code. I'll use Jupyter. So this is Jupyter. Earlier was this was Spider. So Spider is, I don't know why it is not working. Jupyter is working fine. I'll continue with Jupyter. I'll say import pandas as PD. What does it mean? This means I am importing pandas as a library in Python. This pandas is library that is basically used to play with the datasets. Datasets like the datasets in form of Excel that we have. So in case we need to do any manipulation on the Excel type of a datasets, then we use pandas. Okay. I'll say run this. This is this has been imported. The next line which I'll say as in this line only, import numpy as cp. I'll say run. This has been run. So both the things are imported. So this is used to do numerical calculations like np dot sum. So it is not giving me. I'll show you. How it is giving me in sense. It's giving a bit slow here. I'll say np dot move it here. I'll say np dot abs minus 20. Run. It will be value of 20. So all the numerical calculations which we need to do is through numpy. Another library is import. So in case this numpy has certain other libraries that has been stored. So I'll say import sklearn as sk. Let's example. I'll say that. Let's say run. It has been run. So in case sklearn is a class in which there are certain other libraries that have been stored. I specifically want those libraries. Then I'll show you how to use it. First, I'll tell you. Here I'll say from sklearn dot model selection import train test split. Don't worry about it. I'll explain you what is this. Say run. I'll explain this. Don't worry. So I'm just telling you how to import the libraries. So now, right now we are working on a linear regression. So I'll say from sklearn import sklearn dot linear model import linear regression. So this is the way I imported linear regression from sklearn. Let's say from sklearn import metrics. Don't worry, I will explain this. Okay. So is this noise problem with everyone? So everybody is facing. So everybody cannot hear me clearly. Okay. Sure. 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 I'll get. Sure. I'll get another headphone from tomorrow. Sure. Actually, the area where I live in is some function going on just near to my house where I live. So yeah, yeah, yeah. Sure. So tomorrow I'll get another handset as well. So today also I have been wearing a handset. So tomorrow I'll get another handset and I'll try to make sure there won't be any noise. So are you guys clear till the point I have basically like till the way till the point I explained you? Okay. Anybody any doubt till here? Okay.
Hello, sir. Hello.
Yeah, Vijay.
Yeah, sir. Can we do the means reverse prediction? If we if we pass the dependent if we pass the dependent variable, can we get the independent variable?
Yeah, so it's based on the user choice, which variable the user wanted to be dependent or independent.
No, 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 sir. Means we have trained the model according as per convention. That is, we are fixing the dependent variable and independent variable.
Hmm.
After training the model, can we do the reverse prediction?
So no, you need to train the model again.
Okay.
Okay.
Yeah, yeah, sir.
Then I am coming to this only. Okay. So I have a data. For example, I see I have a data or not. So I have a data. Hmm, I have this data. I have this data with me. This is how many rows? It's 241 rows. I'll save this data. So class name one. I'll save this data as regression. So this is the data I have. So what I will do in this Jupyter notebook, I will import this data to Python. I say data is equal to
Sir, your screen is not visible.
okay.
Hello, sir, your screen is not visible yet. No, this is.
Is it visible to all?
Yes, sir.
Yes, sir.
So the data is equal to ed dot read. I need to read the CSV file. And file is class one. Let me save like this. Save no problems. Save. I don't know why it is being saved. Save. Just a second. This data file save as Excel. Excel workbook. This data I say. Say come here. Class data Excel and say come here. Read. Read. I need to here again say file as save as CSV. These are both the options. You can read the Excel and you can read the CSV. I'm not getting the instance of reading the Excel. Read.
So the Jupyter notebook is not connected.
Yeah. Again, it is not working.
You had closed that. What is that? the Python Jupyter folder previously. You had removed that, so it won't work.
Oh, actually, I work on Spider only, so I don't know too much about Jupyter. I'll say I'll copy it, I'll say I'll close it, and I'll open the Jupyter again.
Yeah.
Say open new one.
It will not take. So I mean, you from your search box in Windows, you'll have to install that Jupyter once again. That command prompt that was closed. Yeah, this should be open for it to work always.
The major of the time I work on a Spider, so I paste all this, run, say dot read underscore CSV. I'll copy the path of this file to this folder. Okay, this Excel file, this CSV file. It has, in case it doesn't work, then I'll option copy as path. The problem, I'll say reg.data. This path, I'll say first file, this path, copy, I'll say this, I'll say yes, we have it. Okay, I'll enter R here. I'll tell you why I enter R. Don't worry about it. I'll tell you. I'll name it in file. Say that is equal to brace and I'll say run. If I see what is that, say that and then run it to the entire file here. That's 240 rows, whatever rows we had. It is showing all these rows here. So why I entered R is because I can skip this R as well, but in that scenario I either need to make it as a double slash, like this everywhere, this, or everywhere I need to change it to backslash. Just to avoid this, if we'll enter R here, so it will consider it as a double slash. That's why I took R here. So that is the thing that I got it here. So today I will cover till the point I have read the data. Tomorrow I'll show you the regression and I'll also cover some of the basic concepts of Python along with the thing that we have seen today. So I guess we should, yeah. So yeah. R stands for raw string, which basically says that whatever path has been entered, it will take it as a path only. So there we don't need to enter double slash or the backslashes and all that. So I will cover to the point where it says how to read the data in Python in this lecture, and surely in the next session we will be covering the regression, and some basics of the Pythons as well. So I actually want to tell you some of the techniques which basically says how to remove the or how to impute the missing values and many more. So, but before that, I need to cover the basics of Python as well. That I will also cover along with this session. So that actually I'm not sure how much basics you know about the Python. Like you know how to like iloc, lock, ix, all these things you know or you don't know, because I have been taking this session from the interim only. So
Sir, I have a question.
yeah, yeah.
Sir, when we find the best fit line, so does the best
Mhm.
fit line passes through the mean points like x bar, y bar?
No. So that best fit line is a line that passes in between or near to the actual values, so that there can't be any other line that can be so close to these points. So the sum of
So,
square errors, yeah.
so every time we calculate the line uh, regarding calculating the residuals, right? The error,
Uh-huh. Uh-huh.
and, and which are the least the that fit the best fit line, right?
So the residuals are the ones that is the difference between the actual line and
The predicted one.
the predicted one. Predicted one comes through the value on the line. Actual one is the actual dot that we have.
So it doesn't pass through um, like mean points.
So it passes. So it is not a mean point. It is the best. So it might be scenarios it tries to pass. So the okay, let me come here. So this line tries to pass from each and let's example this line is like this, like this. So now it is passing from each and every point, but the line cannot pass from each and every point, because if it passes from each and every point, then it will not be a straight line. So it has to pass from any of the area between these points. So it can pass like this as well, it can pass like this as well, it can pass like this as well, any of the way it can pass through. But from anywhere it is passing, we need to make sure, or the system needs to make sure, that it is closest to all the points, not a single point. Considering the difference between actual and predicted, it should be closest to all the points. Are you with me?
Okay, sir. Yeah, sir. Sir,
Okay.
and the error
So that is,
part
yeah.
is the biases, right?
Uh-huh. Sorry, come
The
again. Error
error
part.
stands. Error part are the biases, right?
So you are breaking, so you can
Biases.
write down. I'll your voice is. So your voice is breaking. You can just write down your uh, doubt in the comment box, and I'll. So Sovik, you are breaking. So you can write your doubt in the chat box, and I'll explain it. No, not exactly. So, Sovik. The thing called variance and bias through over interpreting. So I'll come to that, but that's similar to that, but that is not that what the exactly the error is. But I'll come to that during the subsequent sessions.
Okay, sir.
Okay. So I am wrapping the session here.
Sir, I have a
You
doubt,
can
sir.
add,
Uh,
please.
Sir, the data on which you're teaching this linear regression, is it available for us so that simultaneously we can also practice on that data?
Yeah, yeah, yeah. So yeah, I'll just give me a second. Is there any way to attach file here?
So there
Or
Under
there is a,
meeting details, you can attach. Left side, you'll have something called meeting details. At the bottom left,
meeting
it should be
details?
there. For you under data science, machine learning, class 1, right? If you just click on that, you'll get that attachment
Okay,
at the
here.
bottom left.
Okay, here.
Bottom left,
Here.
left. That's to the right. Move
Here.
on to the left, actually. Yeah, click there. You'll have on attachment.
Attachment. So how can I attach here? No idea. So what you can do, any one of you can give me your email ID, and I will share that on this email ID only. So basically, we will be requiring this dataset tomorrow, and any one of you can pass me your email ID so that you can circulate it with other
So you
people.
can upload on Google Drive and then share the link of Drive.
Sure, I'll do that. So basically, we will be requiring this dataset tomorrow. So before that, I'll do that. And second thing is, yeah, for the recorded lectures, you need to contact the IIBM only. They will be having the details about it. They will be sharing it with you because I'm not allowed to share it with anybody. So they will be the people who will be sharing it. Sure.